All right, ladies and gentlemen, let's take a look at lesson 3.4, parallel lines and transversals. So what we're really going to do is take a look at all of these relationships that we found in lesson 3.3 and take a look at how they're connected when we specifically look at parallel lines being cut by a transversal. All right, so postulate 8. Once again, we're not necessarily looking to memorize that number, but what we're looking to know is that this is about corresponding angles. So if two parallel lines are cut by a transversal, then the corresponding angles are congruent. And so what that means in symbols is if J and K are parallel, we've got this parallel symbol, then the following is true. Angle 1 would be congruent to angle 5. It's that corresponding position above and to the left. Angle 2 would be congruent to angle 6 above and to the right. Angle 3 would be congruent to angle 7, corresponding in the same position, so we're below and to the left. And then angle 4 would be congruent to angle 8. All right, so let's take a look at what we can do with that. Find the measure of the numbered angles. So I need to find the measure of angle 6. Angle 6 is here. Its corresponding angle is up here, which happens to be 60 degrees. So the measure of angle 6 is 60 degrees. Angle 5 is right here. Its corresponding angle has to be above and to the left, which is right here. So it's 135 degrees. And then the measure of angle 2. Angle 2 is above and to the right. 90 is above and to the right. So angle 2 is 90 degrees. Pretty easy if I do say so. So you guys are going to do the checkpoint. And this checkpoint is do now. And then we will check in class. I'm not going to do this with you, ladies and gentlemen, because I think it follows along exactly with example 1. All right, theorem 3.5. Once again, we're not measuring theorem or memorizing theorems, but what we are going to do is take a look at what the alternate interior angles theorem says. And so it says if two parallel lines are cut by a transversal, then the alternate interior angles are, we have a lot of congruent angles in here. So if J and K are parallel, once again we see our triangles there, then the following are true. Angle 3, we need alternate interior. So angle 3 is inside. I need to be alternating, so I need to be on the opposite side. So angle 3 is going to be congruent to angle 6. Angle 4, we need to be in between the two lines to be interior, and I need to be on the opposite side. So 4 is on the right, 5 is on the left. So angle 4 and angle 5 are congruent. So if we take a look, I will do one of these with you. So if we take a look, I need to find the measure of PQR. So PQR, I'm finding this angle here. I know that alternate interior angles are congruent. So if this is 35, I need to be in between the two lines still. So I'm between QP and SR, and I'm going to be on the opposite side. So up and to the right. So this is 35 degrees. So angle PQR is 35 degrees. So you're going to go through and find angle PQR right here, and you're going to find angle PQR right here. So you, this is still part of the example, sorry guys. So if this is 120 here, that means the opposite alternate interior angle, PQR, is also 120 degrees. And then here we have 70, opposite side, up above. 70 degrees. Here's our examples. All right, for number 4, if this is 90, then I know this is 90. And then what that means is these two are alternate interior angles. So the measure of angle 4 is 90 degrees. When I look at angle 5 and 65 degrees, those are alternate interior. They're on opposite sides of the transversal, and they're in between. So the measure of angle 5 is 65 degrees. And I'll leave number 6 for you to do now, and then we will check in class. All right, alternate exterior angles. We are going to be on opposite sides of the transversal. So if two parallel lines are cut by a transversal, then alternate exterior angles are congruent. And as I kind of look at this and I kind of say, okay, angle 1, we need to be on opposite sides of the transversal to the left. This one needs to be on the right, and they need to be outside on the exterior. So if I look, angle 1 appears to be a very acute angle, and so does angle 6 appears to be the acute angle. So angle 1 is congruent to angle 6. Angle 2 is more of our obtuse angle, above and to the right. I need to be outside and I need to be on the left, and so the obtuse angle here is angle 7. So I do use this idea of looking at what ones appear to be the same size, acute versus obtuse, to help me with my measurements. So example 3, find the measure of angle 1 and the measure of angle 2. So let's take a look at this. We know the measure of angle 2 is 75 degrees. The reason for that is that alternate exterior angles are congruent. So I look at outside the two lines, one above and one below, for alternating, and that gives me exterior angles being congruent. I know that the measure of angle 1 plus angle 2 is 180 degrees because angle 1 and angle 2 form a linear pair. So if I look to do some substitution, I substitute 75 degrees. So the measure of angle 1 plus 75 degrees is equal to 180. I'm going to subtract 75 from each side. So the measure of angle 1 is 105 degrees. So now we're looking at the fact that we can do more than one angle at a time within a picture using just one of these theorems. So find the measure of the number of angles. These are all alternate exterior angles, so I want you guys to do now. And then we will check in class. All right, let's take a look. Same side interior angle theorem. So this one's a little bit different than the others because if two parallel lines are cut by a transversal, then same side interior angles are supplements. All right, what that means is the measure of angle 3, the acute angle, plus angle 5, the obtuse angle, same side, equals 180 degrees. The measure of angle 4, the obtuse, the measure of angle 6, the acute, add up to 180. They make a straight line. So let's see what we can figure out here. I want to find the measure of the number of angles. These are same side interior angles, so I know the measure of angle 5 plus 180 plus 80 degrees equals 180. If we subtract the 80 degrees, we get the measure of angle 5 is 100. If we take a look here, angle 6 and the 130 degree angle are same side interior angles, which means they are supplements, so they add up to equal 180. Subtract the 130, and then we get 50 degrees. So now what we're going to do is take a look at using algebra with these theorems. So I'm going to mark what I have here. I've got 125 and I got x plus 15. They're both above, so they could be same side, but they're not same side interior. When we look, they're both above and to the left, which means they're corresponding angles. So when we look at our corresponding angles are congruent. So I'm going to take x plus 15 and set it equal to 125. I'm going to subtract 15 from each side, and I get x is equal to 100. Let me do a little bit better math. 110 there. All right, we've got 3 checkpoints. I'm going to do 2 of them with you. I'm going to mark my angles. I have 120 and I have x plus 35. They are on opposite sides, which means they're alternating, and they're interior. So these are alternate interior angles, which means if I look back, they're congruent. If we look, this is an obtuse angle, this is an obtuse angle. So x plus 35 equals 120 degrees. I'm going to subtract my 35 then I'm going to get x is equal to 85. If I mark my angles, 75 and x minus 2 are on the same side. It's the only thing that we have as being on the same side and on the inside are same side interior angles. And what we know about those two is that x minus 2 plus 78 is equal to 180. So we have x minus 2 plus 78 equals 180. Combine together those like terms, you actually end up with x plus 76 equals 180. Subtract the 76. And so you get x is equal to 104. All right? What I want you guys to do is mark these. Doesn't really fit anything, but what I do know is that this is also 90 degrees. So if I get rid of this mark that they had there and use my mark, now I start seeing some sort of a relationship. So this is a do now, and we will check in class. Guys, this is one of my favorite lessons using all these angles, but we do have to make sure we keep them straight. Have a great day.